Okay, we're going to do a bit of coordinate geometry, and we will do distance and midpoint between 2 points on our plane. So I'm going to draw a graph. I'm going to try and keep it nice and straight here. Now I'm going to label it. So we've got X, oops, it's a bit funny, and Y. I'll just put some lines in here. So we've got 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5. That'll do. So remember, we can have points on here. So I'm going to just draw one here. I'll draw one here, and maybe one here. Each of these has a. Just get rid of that. Each of these has a coordinate. This one would be, well, 1, 2. This one here, we've come across 1, 2, 3, 4. We've come up 1, 2, 3. And this one here, we've come across 1 and gone up by 1, 2, 3, 4, 5. There we are. So I want to work out the distance between these points. Let's do this point here, and we're going to call this point A. I'm going to call this point down here B, and this one C. So distance between A and B equals, let's have a look. Well, we could work this one out. This one's just straight up and down. We can count the number of times we've moved. We've gone 1, 2, 3. That was simple. Now let's do the distance between B and C. Let's draw a line. Well, that's a very bad line, but there we are. Now, this line here doesn't run across our grid lines, so we can't just simply count how many grid lines we've jumped. It's not quite that easy. But what we can do is break it down into how far across we've come and how far up we've gone. So let's look at how far across we've gone. That's 1, 2, 3. Now what I'm going to call this is how far in X have we gone? Like, what's the change in X? So X has changed by, now you don't have to worry about this notation, but it might be something to remember. X has changed by 3. 1, 2, 3. Y has changed by, well, we've gone up by 1. So Y has changed by 1. So what we've actually just done now, we've drawn a triangle. We've said that this line here has length 3, because that's how far across we've come. And this line here, this side of the triangle, is 1. So we now have a triangle of sides 3, 1, and the line we'd like to find out. Now there's a rule that says when I have a right angled triangle, which this one is, the two shorter sides, so this side and this side, can tell us something about the side we're trying to find out. And what I'm going to do is call this side little a, little b, and little c. Now let's call this one A, and let's call this one little c. So length C is what we're trying to find out. Our rule is that we can take the other two sides and we square them, add them together, and then take the square root of that. All you have to remember here is this equation for those lengths of sides. We have the length of one side squared, we add it to the length of the other side squared, we take the square root of that, and that gives us the length of C. So let's do that. A in this case is this 1 squared, add Well, we've got 3 here. 3 squared, square root of that. So square root of 1 squared is 1, 3 squared is 9. So 1 add 9 is 10, square root of 10. So C here, its length is square root 10. Now, that's the Pythagoras way of doing it. What we've done is we've gone, okay, I've gone from this point here to this point. I've had to go across this many steps and up this many steps. Then I've used those two lengths as sides of a triangle and then used Pythagoras to work that out. So let's start this again in a different way. That Pythagoras stuff, there's actually a formula we make out of it where I can give you any 2 points. So let's give this point and this point. The coordinate of this one is 1, 2. So we've come across 2. We've gone up by 1, 2, 3, 4. Up by 4. This one we go 1, 2, 3, 4, 5, 6. And up by 1. So here is our equation. First, I'm going to call this point A, and I'm going to call this point B. Point A's coordinates, I'm going to call x1, y1. Point B, I'm going to call it x2, y2. So x1 equals 2, y1 equals 4, x2 equals 6, y2 equals 1. So these are just the coordinates of our 2 points. The length between A and B, or the distance, so here we are, this dotted line, I'm going to call that AB. So up here, AB equals, here we go. How far across have we come? 1, go across here like that. We've come from here to here. What's the change in x? Is 1, 2, 3, 4. Now you'll notice that change there is x2 minus x1. 6 take 2 equals 4. We've come across 4. 1, 2, 3, 4. So if I were to write that as an equation, I can go x2 minus x1. So the change in x, the difference between the two x values, 6 and 2, the difference is 4. Square that. Now, how far have we changed in y? Let's see. We've gone 1, 2, 3. So the change in y is 3. Now you notice that is the difference between the two y values. Between 4 and 1, the difference is 3. So that is y2 minus y1. Now, that actually, y2 minus y1 is going to equal negative 3, but that's okay, because we square it. This is your equation here. AB, length AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now that looks like a lot of steps, but if I give you 2 points, 2, 4 and 6, 1, all you have to do is rewrite this and fill in the values. So here we are, x2, well, that is 6, minus x1, that is 2, squared, add y2, 1, minus y1, 4, squared. Now this equals 6 take 2 is 4, squared, add 3 squared, square root that. That equals 16, add 9, square root of that, square root of 25, which equals 5. Our length here is 5.